Hello everyone, and welcome to another week of training live webinar series with Scott and Thane. We're both back together. The last time we saw each other was January 17th, and then I went to a trade show, he went to a trade show, vacation, all these different things. You know what? It's Valentine's Day. Time for a reunion. So we're happy to be back. We hope you're all excited. We hope you're all tuning in. We hope you have questions because today we're talking about agitation. I think agitation is one of the most underutilized features on an Orion product. Why is that? Because we get scared to use it. We blow up things. It puts holes in things. We use one setting that works good. We add agitation. Everything goes wrong. Well, you know what? Agitation requires experimenting. Sometimes that's all it takes. Putting yourself out there, experimenting with things. Well, we didn't get to the moon without experimenting, so that's how we do this. So, anyways, without further ado, I'm going to dive right into it today. Agitation, like I said, it's a feature that's on 3 of our products. It's on the 200i2, the 150S, and the 100C. The M-Pulse does not have agitation. The M-Pulse, you just change your power and that's it. Everything else is automatic. But even in those automatic settings, those default settings, agitation is never added. So that is a feature you are missing out on with the M-Pulse, but you get bits and pieces of agitation as you work your way up. So the 100C has some agitation. It's not, you can't control it. You can't customize it. The 150S, same thing, you add more agitation. And then the 200i2, which I have here behind me, you can go in and customize the agitation. Okay, you're probably wondering, what is agitation? Well, let me tell you. Okay, agitation. As we've talked over the last couple of weeks, when you make a weld, you have this slope like we show here on the screen of our 200i2, right? I'm going to go to classic mode, and I'm going to hit reset just so we're at factory settings. There we go. Oh, let's go back to classic though. So if you have a 100C or if you have any welder of ours, aside from the 200i2, if you're in the triangle mode or the square mode, everything basically looks like this. A little bit of ignition, your initial power, and then cool down. Now, if you've talked to us at a trade show, if you've ever called in, sent us an email, and you've asked about agitation, this is typically what we say. When you add agitation to your weld, you're adding little pulses of energy during the cool down of the weld. And then you usually have 2 options. You either have sloped or sustained. Sustained will add even more agitation. So, easiest way to explain, if you're welding at a setting, we'll say 10 watt seconds, and you have no agitation, you'll have 1 weld. Keeping all things equal and adding a sloped agitation, you're going to add a little bit more penetration and a little bit more, what's the word? Crystallization? We have a video that's going to kind of show what I'm talking about, but more breaking down of the metal, moltening the metal to have it form together better. Now, all things equal, and you add the sustained, even more. It's going to add more power, because what it's doing is it's pulsing on that during that cool down of those last milliseconds of your weld. So, this might sound kind of like it's going over our head. I know the first time I learned about agitation, it kind of went over my head. But the key thing I remembered was it adds a little bit more energy to what my weld is without agitation. So a general rule of thumb, if you're doing one weld and you like it, but you want to try it with agitation, bring your power down. Then add the agitation, and it should be similar. But you will see some different moltening, is that a word? Moltening of the metal. So, I want to show a video of what I was talking about with the crystallization, right? If you do a weld with no agitation, you'll have big, for lack of better terms, kind of these cracks going through your weld. And then when you do a lot of welds next to each other, you're prone to having cracking. Okay? By adding agitation, you break down those cracks, those crystallizations, and you get more forming together. So let us show you a video. We're going to show first you doing a weld without agitation and what happens, and then we'll show the video using agitation and what happens. Okay, so this is a weld. Now the second one went, and you'll see that line that we dropped through. And this video is going to replay a couple times. So the first weld you're seeing, that the yellow in the video, or that orangey color, that's like the moltening of the metal, right? And then as it cools down, what happens is it's formed those pieces together. So you get some of those little crack things. Now as you add another weld next to it, it allows for kind of a fault line to go through there to form easier, right? So that metal could potentially crack in that area. Now, we're going to go to the next video. This is adding agitation to your weld. Now you'll see, same weld, starts out with the same bigger kind of crack areas, crystallizing, and then it adds those pulses of agitation on top as the weld continues through its weld process. So as you can see there, by adding those pulses of energy, it's letting the metal continue to kind of molten together and form together stronger, and you'll see there's smaller cracks. Now this is all it's very blown up based on what you're seeing right there. This is all on very small scale what's happening. So you would never see this with the naked eye, but this is basically what's happening when you're adding agitation. So you can see when you do another weld next to the one you already did, there's less likely of a crack being able to form through there. Now, I need to repent. Okay, last week we did a lesson on welding silver. What was a ring resize? Sorry, couldn't remember. Excuse me. We did our webinar was on resizing a ring, and I remember saying, don't ever use agitation. Well, after talking to Dr. Astle this week, the owner of Sunstone and the brains behind a lot of our products and features, we learned that agitation is actually a good thing, as long as you make sure to adjust the power correctly, and will take some experimenting. You'll have to do some trial and error to figure that out. But if you have a setting you like working with silver, just try, aside from resizing rings or working real close to diamonds or stones, but if you're doing like a ring resize or maybe putting a post on, something like that, try taking that setting you like and lowering it for maybe 5 watt seconds, but then adding agitation. Always test on something that's not valuable, but you'll notice that metal will molten more. And I did some tests. I have this ring right here. And again, the key thing to remember is experimenting and trying things. I did I cut the ring here and I cut it here. I did one where I was welding with agitation and one where I was welding without agitation. And when I cleaned it up and I polished it, the one where I used agitation actually looked really good. There was less porosity. There's actually practically no porosity at all. It was sweet. And so like those videos that we showed you just a second ago, when you add agitation to your weld, it helps that metal really bond together better. And as long as you do it right, by lowering the power and finding that perfect setting, you'll get a really good weld. And it looks beautiful after you clean it up. Now, is it to say that not using agitation is any worse? No, it's still good. Do what works for you, experiment, try agitation, but we just want you to know what's happening, what it is, how it's utilized, and where to use it, and maybe where not to use it. And like I said earlier, I wouldn't recommend using agitation ever if I was working next to a stone or a ruby or something of valuable. But a ring resize or putting some pieces together with silver, that's no problem at all. Now, agitation, when you have an Orion welder, we have our basic screen, you select a metal, and you'll see that there's certain metals where we recommend using agitation. Those metals are stainless steel, titanium, and then if you're in the dental lab industry, your chrome cobalts, and what other ones are there?
Titanium.
Titanium, I said that. Nickel. Chrome cobalt, stainless steel, nickel, titanium. You'll notice that we recommend using agitation with those metals because they take agitation well. These type of metals, you can add additional power, and you don't see what you see with like copper or silver, where it kind of will want to make a hole or a pit if you use too much power. So, palladium, that was the other one I was thinking. Palladium and platinum. So, platinum and palladium. I have some notes here, I'm just looking down to read them really fast. So, these type of metals transfer heat and have dissipation, right? So your palladiums, your platinums, if you don't hit them with enough power, that heat that you're hitting it with will just dissipate, and you don't really get much of a weld. You get one, but as when you test it and stuff, it's not very strong. So palladium and platinum, you actually have to, by adding agitation, it works awesome because you're getting that additional heat. It's helping the metal bond together, fuse together very well. So we recommend with your palladiums, platinums, titanium, stainless steel, experimenting and using agitation to see if you can get a stronger weld, a cleaner weld. You won't always get a smoother weld using agitation, but you will get that metal forming together. So, I'm kind of all over the place, so let me just kind of recap. What is agitation? Agitation is peaks of energy added to the downslope of the welding current, like I showed in the video. You have sloped agitation, which follows the slope. Let me go back here. Follows the curve, the weld slope curve, and then you have sustained, where it is higher peaks of energy. And then recently we have added what we call negative agitation. Now, it's exactly the opposite of like a sustained agitation, right? So instead of peaks of energy being added, peaks of energy are being taken away, okay? So if I come here to the negative agitation, you can see that we have our slope, but those peaks are, well, I wouldn't call them peaks, those drops are going down, right? So it initially does the opposite. When you use agitation, like a sloped or a sustained, you get that energy coming out really strong, like a forward boom, almost like a punch, right? When you do negative agitation, it kind of goes out, that energy and that power, right? So, what we learned from this is using a sloped or a sustained agitation is going to hit a little bit harder, you're going to get a deeper penetration, whereas on the negative agitation, it's going, that energy and power is kind of going out, right? So it's more on the surface, and one of the things we've seen with negative agitation is it's great for eliminating porosity, right? Is that right? Yeah, that's right. Okay. So another great one to experiment with. Also, the opposite is happening with negative agitation. Okay, so all things equal, back to that 10 watt seconds, no agitation. Well, if I want to keep all things equal and add negative agitation, I'm probably going to need to bump my power up, 3 or 4 watt seconds. So go from 10 to 14, add the negative agitation. And you'll see something similar, but you'll be getting more of a energy going out instead of directly into the weld. So, Another one that we, obviously invite you to experiment with, and you'll see the difference as you work with different metals and different pieces. So those are the types of agitation. Why is agitation important? It's basically used for three main purposes. Okay, it removes air bubbles and porosity from the weld site. It provides deeper penetration, as I mentioned. So by adding that agitation, you can get a deeper weld. And I noticed on a ring resize, last week we talked about cutting the V into the metal. I noticed when I used agitation that it really brought that metal together, and I didn't have to cut as sharp of a V. I was able to have more metal hanging out on the bottom. And so that was something I found by experimenting with that. It was really cool. And then it assists in closing gaps. So if you ever have, we'll use my fingers here as an example. If you ever have, you're welding something up top, right here you'll see it's come together, but there's a little bit of a gap at the bottom. When you don't have agitation, you'll try to weld where that opening is and it won't bring the pieces together. By adding a little bit of agitation, you can sometimes bridge that gap and bring the pieces together. Again, this is a drastic example. We're talking when you're looking through the microscope and there's a little bit of a gap. As we've taught in past episodes, you want to really try to have your pieces together so that the arc doesn't pick one side and fall up that area. But adding agitation can help to close gaps. And then where is it useful? We talked about stainless steel, platinum and palladium, your dental metals, chrome, cobalt, titanium, things like that. And then, as I said, we've seen with, just get some parts here from Thing. We've seen with our experimenting that it does also assist in working with silver. Again, test out some of the things we've taught from past videos and then apply agitation and see how that works for you. Again, before we do any further testing and trying things out, we still would recommend using our suggested settings, and then you can experiment from there. So let me just go ahead and do a weld really fast, and we'll show you the difference between a weld with agitation or without agitation, and then with agitation. So. Okay, so let me reset here, and I'm going to do a sloped agitation. So my length is at 20 on the 200i2. My power's at 5.4 kilowatts. And I did a sloped agitation. You can hear it. When you do agitation, there's a higher pitched sound. And what that is that's those pulses of energy happening. Again, this is happening in milliseconds. You'd never be able to see it, but you can hear it. So let me turn off the agitation, and you'll kind of hear the difference. Oh, hold on. Let me get a spot here. That's good. So as you can see here, all things equal, the only thing I did was add agitation. So my bottom weld's here. That was no agitation. This was sloped agitation. And now let me add sustained, where you get the higher peaks. I'm still at 5.74 kilowatts and 20 milliseconds of time. All we've done is add sustained agitation. And my pieces weren't together well, so you kind of got some holes there. But again, you can see sustained, sloped, none. So you're getting a bigger weld. If I turn this around, you'll even see the penetration. So you had a deeper weld and it even penetrated through our metal. Now, let me add a little bit of a gap here, and we'll do the method of having a gap. So I still have my sustained on. I've got a little bit of a gap, and let me adjust this a little bit. I'm gonna add a different one here. Okay, so now I have a little bit of a gap. I'm gonna add my sustained here. And you can see kind of a little bit of a hole there, but it bridged that gap and it grabbed the metal. So then you could add metal if you needed to fill in the hole. But then if you just go straight along where you already have your weld here, you'll notice that it's grabbing that metal even though there's a gap.
Go ahead and finish with standard.
Oh, finish with standard? Okay, so I turned that off. You can see it didn't grab quite as much. But since we had some going there, it's able to grab it. But you can see the difference in the size there. And you're getting a much stronger weld with that added agitation. So, there we have our welds. You can see here where that weld went all the way through, where the couple I did with no agitation, it didn't even come through to the other side. So,
and again, nothing changes but the agitation added.
Yeah, nothing changed, as Thane said, except we just added agitation. So, as you saw, the weld spot size went from here to here just by adding agitation. All other things stayed equal. So, one thing I noticed last week is I told everyone if you had questions to email sales@Orion Welders. But then when we close the video off, it says sales@Sunstone Welders. So, just to clarify things, Sunstone Welders and Orion Welders, it's the same. Sunstone is the parent company, Orion is our pulse arc welders and laser welders. So, you can email us questions at either email address. The one you see at the beginning and end of the videos is sales@sunstonewelders.com. We'd love to hear from you. Do we have any questions that have come in today? All right. So, if you have any questions, let us know. We hope that this video helps you to understand agitation better, the theory behind it, why you would potentially want to use it or not use it, and just remember to go out there and try it out. And if you have questions, let us know. We're more than happy to help. We love helping. We love experimenting with you guys and learning together. So, thanks for joining us, and we will hear from you when we hear from you.